All right, the function's defined here. It's a square root graph on this interval. Why did they have this interval? Well, isn't everything outside the interval non-existent in the real? Anything outside would be imaginary. So if I want the derivative of it, you just take the derivative of this. You do not have to simplify it, you guys. Technically, I wonder if they would even accept this right here. They might even accept that, but I would probably go to this step at least. I don't think you really need this interval, even though it's kind of true, because when the edges give you 0, but I don't think you really need that. It doesn't say you need that. It doesn't say to give me the interval of domain, but anywho. So for the derivative of this, don't you take the outside, the 1/2, square root's 1/2, you drop the power by 1, you leave the inside, and you take the derivative of the inside, and then you're done. Hopefully that was an easier question. Now, write the equation for the line tangent to the graph at this. Well, if we want the line tangent to a graph at this point, well, don't you simply have to find the slope at that point and the coordinate at that point? You got the slope formula. And what if you messed up on your slope formula here? Would you still get the points for this? Yeah, even if you messed up right here, as long as you plug -3 into whatever this was and got this, you would still get the answers. They would look at it, which is kind of nice. So you find the slope at -3, you find the coordinate at -3, and then, as you can hopefully tell, you put it all together. And when you put it all together, you just, technically, I would put y minus 4 here equals this. But they moved it over. You don't have to rewrite it. You could just put y minus 4 equals this process. It depends on if you point slope or slope intercept form. Your choice on what format you want. But hopefully you're okay with that. All right, for this one, C, let g be this function of piecewise, which uses f of x on the left of -3, on the right of -3 using x plus 7. And it says, is it continuous? Hopefully that will be easy. The second part of justifying, explaining, might be a little bit tough because you might not remember the continuity definition, which I even forget all the little pieces of it. So let's take a look at their answer. Okay, kind of a lengthy answer here. So let's take a look at this. First of all, to make sure something continuous, don't you have to find the limit on both sides? On the left side, wasn't it this function? And on the right side, wasn't it this function? So all you do is you plug in -3, they got 4. You plug in -3, they got 4. So is the value the same from both sides? So right off, could you tell it is continuous from that? If the limit from the left is 4 and from the right it's 4, they should be the same. So therefore, the limit at -3 is 4. So I know the limit there is 4 because the definition of a limit is they approach the same from both sides. Limit from both sides is the same. The limit there is the same. And then thus, also you have to show that the value of each, that's 4. Thus the limit equals g of -3. They're just kind of getting more details on the definition of limit. Basically, with this problem, you need to prove that the limit from both sides is the same. You need to prove that the value exists, and that the limit exists. You have to make sure that the value isn't look like this. Here's the key. You don't want it to look like this and like this. The limit could exist, right? But then what if the point is up here? You got to make sure you don't have some point just randomly sitting up here. Got it? So you have to show that the value is the same for both of them at that point. Not just the limit approaching, but the value is actually existent there. It's kind of stupid for this question, this idea. All right, for this last question, you're taking the antiderivative, the integral, over this interval. Be careful, this is a U-substitution. So when I pull this up, let's take a look at their work here. First of all, you have to know the inside of this is your U. When you take the derivative of it, you get -2 dx. So when you replace this with U, what do they do with the interval? How they get 0 and 25? Do you understand they plugged in 5 right here? And then they also plug in 0? Got it? When you plug in 0 and 5 right there, when you plug 0 and 5 right there, the top, when you plug in 5, you get 0. When you plug in 0, you get 25. They change the interval. Were they at negative 1/2? Well, don't they divide this over because of U-substitution? The integral of u, square root of u, isn't that going to be u to the 1/2? So won't that be u to the 3 over 2 divided by 3 over 2? And then don't they put in 0 and 25 and subtract? Just remember, lastly, when you put in 0 and 25, if I have, for instance, 25 to the 3 over 2, this might confuse you, isn't this saying square root of 25? Cubed. Isn't that what it's saying? The square root of 25 cubed, which is 125. And 0 is pretty easy. All right, so there's a lot of little details, being careful with this problem. Again, you might want to change the interval. Do you have to change the interval? No, you could have left the interval. Just make sure in the end you want to have u's here. You'd be putting, 25 minus x squared back in. And I honestly would change the interval because technically when you write your problem, if you don't change the interval, it's written improperly.